Yeah, guys, what happened? Send the answers if you are done. Okay. No, okay, somebody has sent the answer. Just a second. Just a second, Salman. Yeah, I think that is right. Yeah, yeah, Meenakshi, that's correct. Very good. Somewhere around that number.
Somewhere
around that. Yeah, tell me, Asta.
So for like 30% decomposition, should we take like directly 30 or like that 100 by 70? I mean, no.
I mean, see, A0 will be 100. I think you know that, right? There's no confusion about that. What will be the remaining concentration? If I'm saying that 30% has been decomposed, 30% has reacted, what will be the remaining reactant?
70.
Yeah,
70.
that's it.
Okay, so the same as completed only.
Yeah, same thing.
Okay.
So first of all, you will get the K from the integrated rate law equation, and from there you can calculate the T half. Hope you remember the formula for T half. Yeah, that is correct, Khalid. Very good. Okay, so see guys, look here. We've got our A0 and our A. Now we can say that the K will be equal to 2.303 divided by time log of A0 upon A. So we know the time here, we need to calculate the K, because essentially you have to calculate the T half, and T half for a first order reaction, it is what? 0.693. 0.693 divided by the rate constant K. So we need to calculate the rate constant K. Okay, so this will be equal to 2.303 divided by the time. The time is 40 minutes. So we'll just write 40 and log of 100 upon 70. So this will be 2.303 divided by 40 log of 10 upon 7, right? So I can write this as 2.303 divided by 40 and log of 10 minus log of 7. So log of 10 and log of 7 will be equal to how much? 2.303 divided by 40 into log of 10 is 1 minus 0.84. It will be what? 0.16. Okay, so this is the number that we are getting. Then we are going to plug in the value. That log is equal to, sorry, t half is equal to 0.693 divided by the k. And k is what? 2.303 into 0.16 divided by 40. So 40 we can go above because denominator of denominator is numerator. 0.693 into 40 upon 2.303 into 0.16. So I think 2 3s are, I can maybe say, right, approximately. So I can say that this is 0.3 into 40. So 0.3 into 40 divided by 0.16. Calculate this number and you will get the answer. 4 3s are 12. So it will be what? We're getting 3 by 4, right? Yes, guys, 3 by 4. 12, sorry, 4 3s are and 4 4s are. So 3 by 4 will be what? 0.75. So we can say that into 10. So it will be approximately 75 minutes. All of you done yes or no, please tell me.
1 minute, sir.
Yeah.
Sir, I got 77 minutes.
That's fine. That's fine. I mean, I am the one who has approximated things here.
Done, sir.
Done. Is everyone done?
Yes, sir.
Okay. Fine. So what did we learn the last time? Actually, there is one more question. To try this one also. I mean, it's a bit big question, but you can try this. Same concepts are being used here also. Okay. So all the nuclear explosion, so our teacher does, we are getting log values for boards as well. Congratulations, Salman. If you are getting the board value, sorry, the log values in the board, but I am preparing for the worst. Okay. I know that like people do get log values, लेकिन हम जो तैयारी करा, like what I do here is that when you're going to do exercises in NCERT, NCERT has not given you log values. So there will be friction. कि आप एक सवाल कर रहे हैं अटक गए, log आया, log में आप अटक गए. So I don't want that friction. You should be flawless. एक ना बीच में एक आदमी को डर लगा रहता है, किसी चीज से डर रहता है ना, और डर लगा रह जाता है पढ़ाई लिखाई के मामले में. मान लीजिए आपके पास बाइनोमियल थ्योरम, जिनका मैथ से बाइनोमियल थ्योरम नहीं आता, लेकिन कहीं और अगर बाइनोमियल थ्योरम इस्तेमाल होने लगेगा तो फिर वो डर बैठ जाता है. So that is why I teach log. So I'm saying that all whatever nuclear reactions happen, it happens in first order always. Okay. Now, I hope your mind is working in a way that you need to find out A and A naught and A. You have to find out A naught and A. Your mind should be working in these terms only, because the half-life has been given. So if you have been given the half-life, then you have also been given what? You've also been given the rate constant, right? So you have the rate constant. Think about this, that you have the rate constant already. What is the A naught? Like if someone can identify the A naught, then it is going to be really well. From this question, just by pure English, okay? Like A naught is given in the question, okay? So you have to identify what is the A naught here. What is the initial concentration? Think in terms of then, it's not given directly, obviously. Think in terms of at least how much is initial reactant. What is the amount of initial reactant? Yes, that is correct, Muhammad Umar. No, it is a number, Khalid. वो आपके सवाल में दिया हुआ है. I mean, it is a number that is given in the question, the A naught. Yes, Minashi, correct. But ask the unit. Okay. Now, you can calculate the K. This K will be approximately equal to 0.025. Year inverse, okay? 0.025 year inverse. This is your K, okay? Now, if you see here, they are saying that 1 microgram of strontium was absorbed by the bones of a newly born baby instead of calcium, okay? How much of it will remain? So what they are asking, how much of it will remain after 10 years? That means they're asking how much A will be remaining after 10 years. How much A will be remaining after 10 years? So if you see this question, they have given you time. How much time do you need? 10 years, okay? What is the K? I have given you the K, I mean, indirectly via T half, okay? And what is the initial concentration? Initial concentration is 1 microgram, that is already given. So here we need to just find the A. So please write, we can write what? Log of A naught upon A is equal to 80 by 2.303, right? So the K is 0.025 year inverse into the time is what? 10 years. So it will be 10 year divided by 2.303. This is your log A0 upon A. This will be equal to what? 0.025. 0.25 year. Now year and year will cancel each other. Divided by 2.303. Okay. Now what do we have here? Log of A0. A0 is what? What is the value of A0? Value of A0 is 1 microgram. I can write that the remaining amount of X is going to be what? So the remaining amount of A is going to be some X grams. This will be equal to 0.25 divided by 2.303. Correct. So calculate this number first of all.
So 0.10.
0.10. 2 non-zero digit after decimal point. 10.
0.1085.
108. So we can take that 0.11. Correct. So this is the value of log 1 upon X. Okay. So here we have 10 to the power 0.11 will be equal to, so we can write 1 upon X is equal to 10 to the power 0.11. Right, things? Yeah, I think that's right. Now X will be equal to 1 upon 10 to the power 0.11. As this value 10 to the power 0.11, it roughly approximates to 1.2, 1.3, something like that. 10 to the power 0.11. By the definition of log, so in microgram. So log, it has a base 10, 10 to the power 2 is equal to 100, right? So I need to remove this particular thing. So I have just written this 10 to the power 2 is equal to 100 from here. So I have removed the log. How I removed the log 10 to the power 0.11 is equal to 1 upon X. Got it now, Mohammed Umar? Yeah, okay. All of you done? Is on a piece of me? Yeah, आपके आंसर यहाँ पे हो जाएगा 1 upon 10 to the power 0.11. It is approximately 1.2. I think it's approximate to 1.2.
Sir, you can write it as 1.3. Yeah.
Sorry.
No, I was gonna say you can write it as 1.3.
Yeah, 1.3. Somewhere around 1.3. Yeah. Micrograms. And so 10 upon 13 will be what? 0.76.
0.76.
So this much micrograms will be remaining in the body. Like this is for 10 years. Okay. Now, there is another question. It is about after 60 years, how much will be remaining? So what you need to do is you just need to plug in the value 60 here. And then you will get the answer for that also. Okay, is everyone done? All of you wrote this? All of you wrote this, Asuna, please tell me. No, still writing. Oh, not done, still not done. Okay, those who are done, you will write the topic. Temperature dependence of rate. Temperature dependence of rate. Okay, write with me. Write the first point. According to polygen theory, the rate of reaction will increase. The rate of reaction will increase with increase in frequency of effective collision. Now, if there are more number of effective collision, then that would lead to what? That would lead to increase in the rate of reaction. Okay, please write next. On increasing the temperature, the velocity, or we can say the kinetic energy of reactant molecule will also increase. This will lead to more number of reactant molecule with kinetic energy greater than threshold energy, resulting in increase in the number of what? The increase of number of effective collision. And hence the rate of reaction increases with increase in temperature. After this, you can draw this diagram. It doesn't need to be accurate, okay? What it shows that, as you can see, if I take a value of kinetic energy somewhere here, okay, let us suppose this is the cutoff threshold energy, okay? Whatever is after this, it is what? After this, the kinetic energy is greater than the threshold energy, okay? So this point here, it is my threshold energy. So you can see that if I have hot gas, then what is going to happen? Then more number of molecules are there, which is having kinetic energy greater than threshold energy. If I look at the room temperature, there is a tiny bit of it. If I have cold gas, then it is going to be not, I mean, you can see that there is no molecule that is after the threshold energy. Okay, so again, this threshold energy is obviously imaginary, but you can put the line anywhere else. Okay, you can put the line anywhere else in this region, and it is going to be the hot ones having more number of molecules that have kinetic energy greater than threshold energy. I mean, the above lines are self-explanatory. If you have any doubt, then please let me know. I think these are self-explanatory. If you increase the temperature, there will be more molecules with more kinetic energy, and if there are having more molecules with more kinetic energy, they will be showing effective collision. And if there is more number of effective collision, the rate is going to increase. So that's how the logic goes. Cold gas is highest number of molecules. All of them are having same number of molecules. According to graph also, all of them are having same number of molecules. According to graph also, all of them are having same number of molecules.
So
Speed of
should we
reaction.
draw this?
Yeah, draw this. Graph is just showing the speed of reaction. No, it is showing the speed of the molecules. Speed of the molecules and the number of molecules with that speed. Okay. So don't try to like as an overview nahi hota graph. Okay, you will get graphs can be delusional sometimes. Okay, Mohammed Umar. So pinpoint a point in a particular plot, cold gas ka, room temperature ka, hot gas ka, and what does point signifies? Try to understand that. Take any point for that matter and think about that point. What does it signify? And how are you going to do that? You take this point here. If you imagine that this is the point that will be interested in you, right? So it represents that the number of molecules with this particular speed is this much. Okay, so what it is representing that most of the molecules in the cold gas are having this kinetic energy and this speed. Most of the molecule in room temperature are having this speed, and for a hot one, this speed. So tell me which is having the highest speed. Yeah. You got a bit of clarity that number of molecules is same in all of them. But number of molecules corresponding to a particular thing, it is different in different things, right? To a particular speed. But the speed of individual molecule for different temperature is different. That is right. But the speed of individual molecule for different temperature is different. I mean, I don't know why the but was necessary. What is the but implying here? Obviously, if you're having different temperature, the speed of a molecule is going to be different. Done, everyone? Is going to be me?
Yes, sir, done.
1 minute, sir.
1 minute. इसको देख के बनाना जरूरी नहीं है ना सैफ, ये देख के बनाना जरूरी है?
Done, sir.
अच्छा. Okay. So you have to choose the correct option. Correct order of temperature will be. What do you think? Like the first is having the highest temperature, then the second, and then the third. I mean, इसको आप 2 लिखिए, इसको आप 3 लिखिए, ठीक है? Or it is
So what's
something
the
like
question?
correct order of temperature. What will be the correct order of temperature? You have shown 3 graphs, and what do you think is the correct order of temperature? The number of molecules divide, I mean the fraction of molecules, you can say. You can take this as A also. Number of molecules, same thing. Which plot? The first plot signifies that it is going to have what temperature? Not exactly, but relatively आपको बताना है. Which is going to have the highest temperature, and which is going to have the lowest temperature. No, you have an option here. A, B, or C, or D. ऐसे बता दीजिए आस्था, that will be very better. I think you have gave the right answer. Yeah, correct, Astha. Yeah, that is correct, Muhammad Umar. Yes, Nabil Ahmed, correct. Yes, Minashi, correct. Very good. So what you needed to do is you just need to drop the plots like this. So most of the molecule in the first plot, it is having this speed. Most of the molecule. For the second one, it is having this speed. And most of the molecule in the third case, it is having somewhere this speed. So obviously we can see that 3 is greater than 2 and it is greater than 1. Right? On increasing the temperature, Maxwell-Boltzmann distribution curve shifts rightward. and write a note. As a general rule of thumb, as a general rule of thumb, the rate of reaction doubles on 10 degree or 10 Kelvin increase in temperature. Now, right next, Arrhenius equation.
Sir, could you show the blue text again?
Arrhenius, he studied about how the temperature is going to affect the rate constant, and obviously, since the temperature is going to affect the rate constant will further affect the rate of reaction. Okay, so Arrhenius did multiple of experiments, and from those experiments he got the data, and then he found a correlation between the temperature and also the rate constant. So he gave an equation. Please write. What is this Arrhenius equation? The equation which gives the relationship between temperature and rate constant Just a second. Okay, I'm sorry. पता है आप लोगों को like nearby town only there is a wedding, a close relative की. So nobody is at home. I did not go because आप लोग को पढ़ाने का नहीं बन पाता वहाँ पे फिर. Okay, the equation which gives the relationship between temperature and rate constant is called Arrhenius equation. Arrhenius equation. So he found out that the rate constant K is equal to, first of all, there is a constant and it depends on e to the power negative of EA, that means the activation energy, divided by R times T. So E, the value, what is E here? I'll write all of these terms, please see. First of all, what is K? K is rate constant. Okay, what is A? A is Arrhenius or pre-exponential factor. EA is activation energy. R is your gas constant. And in this case, we are going to take it as 8.314 kilojoule per Kelvin per mole. Okay. Then temperature is going to be T is temperature, and we will take this in Kelvin. And E, it is a constant whose value is equal to 2.718. Okay. All right. Write some remarks here. A and EA, the activation energy and the pre-exponential factor or the Arrhenius factor, are characteristic for a reaction. That means these two are not going to depend on temperature. Okay, Arrhenius factor, the pre-exponential factor, and the activation energy. Both of these things, they do not depend on the temperature and all. It just depends on the reaction. If the reaction is different, then the A is going to be different, EA is going to be different. But if you are going to do this reaction at any temperature, the activation energy and the pre-exponential factor, it is not going to change. The next one, please write. These two are collectively known as Arrhenius parameters. Arrhenius parameters. Okay. Now, if you look at this equation, just a bit like not playable. That means you cannot solve these type of equation in which the power is of 2. E is what 2.718, and you have the power to it, so you cannot solve it obviously. So we will put it in terms that are easy for us to solve. E to the power minus EA upon RT. Now I will take log on both sides. Now whenever we can never take the log base 10. We only have to take the ln. Take ln on both sides. Natural log has a base of E. So you'll get ln k, which is equal to ln of A into E to the power minus EA by RT. Okay, so now I can write this as ln A plus ln E to the power minus EA upon RT. Okay, now please show me log of E to the base E will be equal to how much? Tell me guys. E to the power how much will be equal to E? E to the power how much will be equal to 1, right? Okay, fine. First of all, I need to get rid of this EA. So this exponential part. So I can write ln A plus the minus of EA upon RT from the power rule, I can say that, into ln E. Now ln E will be equal to what? 1. So I can further write ln A minus EA upon RT. This is equal to ln K. Okay. Now I need to convert this natural log to log 10. So I will multiply 2.303. So 2.303 now it is of log base 10. Log K is equal to 2.303 log of A minus E upon RT. Now what will be this equation? I will divide the 2.303 on both sides. So this will become log K is equal to log A minus EA upon 2.303 RT. So this is the final equation that we have to learn and memorize.
So
Yeah, Tony.
so like in the first steps I've written ln. So like there also like we can use log, right? It's the same thing, ln and log.
No, no, not the same thing. आप यहाँ पे देखिए अगर उस टाइम हम लोग log जब भी लेते हैं ना, so we can take natural log, okay, on both sides, starting with natural log on both sides. And also one more thing that why we are taking natural log is, see, फिर ये नहीं हो पाता ना, right? We would have got something like this, log to the base 10 of E. So directly answer नहीं आ पाता. Are you getting my point?
Yes, sir.
Then guys, this will be me.
Yes, sir, done.
Okay. Now from here in this equation, you can see that what is going to happen if we increase the temperature. So please see, if we are going to increase the temperature, then what is going to happen? This complete denominator is going to increase, right? The denominator is going to increase. Okay. That means if the denominator is increasing, that means this fraction will become less. I can say the fraction values decreases. If the fraction values decreases, that means the negative part value is also decreasing. The negative part value is also decreasing. If the negative part value is decreasing, that means this complete thing is increasing. The RHS is increasing. And if the RHS is increasing, obviously the LHS will also increase. Okay, so if I increase the temperature, then what happens? What is in LHS? It is the log K. So we can say that the rate constant also increases. So mathematically, we can also see that on increasing the temperature, the rate constant is going to increase. Okay, so right after this, it is evident. that on increasing temperature, there will be increase in the rate constant. बताइए मोहम्मद उमर, समझ में आया अब नहीं आया? ln of E means log of base E. Okay. E raised to E. अरे नहीं भाई, आप लॉग नहीं पढ़ के आए। लॉग आप पढ़ के आए। लॉग में एक बेस होता है कि नहीं होता? मैसेज नहीं कीजिए अब, आप माइक ऑन कीजिए। यस सर, मोहम्मद में क्या प्रॉब्लम हुई है आपको यहाँ पे? यस मोहम्मद में जल्दी बताइए। Can't hear you.
Don't know, sir.
Sorry?
I don't know.
You don't know? What you don't know?
I don't know what's the problem.
I'm saying, so there is no problem, right? Okay, right? Graph of log K. Versus 1 by T. Okay, so we have our equation which says that log K is equal to log A minus EA upon 2.303 R. And then I can see 1 upon T. So from here you can see that I can plot a graphs such as this is my Y. This is equal to, this is my C, and this whole thing is my M, and this whole thing is my X. So it is the graph of Y is equal to MX plus C. So please plot it like this. Now, here we are going to keep the log of K, and in this X-axis it will be 1 by T. And as you can see, the M is what? The slope is negative. So it will be something like this. And this point here, it is signifying log A. Okay. And what is the slope of this graph? Minus EA upon 2.303 R. All of you done? Jasola, please tell me.
Yes, sir,
Yes,
done.
sir.
All right, next, Arrhenius equation at 2 different temperatures. Arrhenius equation at 2 different temperatures. Okay, so we have noted one point, just rewriting that on every 10 degree or 10 Kelvin increase in temperature, the rate of reaction doubles. The rate of reaction doubles. Right, next point. The ratio of rate constant at two different temperature, with difference of 10, degrees Celsius or 10 Kelvin is called temperature coefficient. Temperature coefficient is equal to K at any temperature plus 10 divided by the K at that temperature. Okay. All of you done, Jasola, please tell me.
Yes, sir, done.
Okay. Now this was for only when you have a difference of 10. Now please write
So 1
Arrhenius
minute, sir.
equation. Okay. Arrhenius equation at T1 and T2 for a reaction. Okay, so we can write for the first reaction, I can write log of K1. Log of K1 is equal to log A minus EA upon 2.303 R T1. Okay, and this is for temperature T1. At temperature T2, the K will become K2. Now, since for a reaction A and EA are not changing, this will be same EA upon 2.303 R into T2. Okay, so this is for the first one. This is for the second one. Now, if you are going to do 2 divided by 1, then what we are going to get? So see, we are going to get log of K2, or rather, wait a second. We can also do 2 minus 1 we can do, because log है तो उसमें बराबर हो जाएगा बाद. Let's do 2 minus 1. Okay, so log K2 minus log of K1 will be equal to log A, this part, minus EA upon 2.303. This is T1. R of T1. Okay, minus we have log of A minus EA upon 2.303 R T2. So from here you can see that both of this log A can get cancelled because this is in positive, and when the bracket will open, this log A will become minus log A. So plus log A minus log A will cancel each other out. Okay. Now this log K2 minus log K1, I can write it as log of K2 upon K1, which will be equal to, now here we can see that which is going to be in positive. Okay, sorry. I think I did a mistake, right? This is going to be T2 and this is going to be T1. T2 and T1. Yeah, because K2 is here, so T2 will be here. Okay. Next thing is, now this is minus EA upon 2.303. So this will be in minus only, and this is going to get positive. So I can write EA upon 2.303 R of T1, because T1 is going to get positive, minus EA upon 2.303 R of T2. I can take EA upon 2.303 R as common. Log K2 upon K1 will be equal to EA upon 2.303 R. And here I will be remaining with 1 upon T1 minus 1 upon T2. Further, if you want to simplify, you can write something like this. K2 upon K1 is equal to the activation energy upon 2.303 R. Now this will be equal to what? T2 minus T1 upon T1 into T2. Now you can take the LCM and then you can like this. Here you will get T2, here you will get T1, and in the denominator you are going to get T1 into T2. Okay, so write this down. Let me know if you have any doubt in this derivation. This is an important one.
Done, sir.
Is anyone still writing?
That's it.
Done? Okay, right. Okay. Now, write the topic factors affecting rate of reaction. So we have seen a few factors. So the important factor that you have to remember and whatever the effect is going to be is number one is concentration of reactant. Number two is the physical state. Of reaction. Number three, temperature. Number four is catalyst. Right, number one. Concentration of reactant. We have seen this from rate law expression that the rate of reaction is going to increase on increasing the amount or the concentration of what? Concentration of reactant molecule. Please write. The rate of reaction increases on increase in concentration of reactant molecule according to law of mass action. Okay, according to law of mass action, as if we are going to increase the concentration, then what is going to happen? We'll have more moles of or more number of particles of reactant in the same volume. So the number of collisions will also increase. Law of mass action, as the number of collisions would also increase. Now, physical state of reactant. इतना टाइम नहीं लगना चाहिए था. I am going to write these points again. ठीक है उमर, I am going to write these points again. 4 पॉइंट है, आप जगह छोड़ दीजिए वहां पे, है ना. Right here. Now, if I talk about physical state of a reaction, then if there is a reaction in which we have only solids, or if we have only liquids, or if we have only gases, then those reactions, they will be reacting faster because they don't have to change the state. For example, if something is going, the reactants are also solid and the product is also solid. So the reactant, they don't have to go over a phase transition. So obviously that is going to be faster. Now, if I have liquid, then it is going to be faster. If gas, it is going to be faster. So homogeneous reaction, that means whenever you have, please write rate of homogeneous reaction is always greater than rate of heterogeneous reaction. That means the reaction involving one phases in the reactant and product, that is going to be faster than those reactions which involve different phases of reactant and product or different phases of the species. And for homogeneous reaction, the solid plus solid will be the slowest because particles will not collide as rapidly, followed by liquid plus liquid, followed by gas plus gas. Factors affecting rate of reaction. Topic is factors affecting rate of reaction. Right, third point. Temperature we have seen just now. As the temperature increases, kinetic energy of reactants increases. Kinetic energy of reactant increases. Therefore, number of effective collisions number of effective collisions increases. Which leads to increase in rate of reaction. It leads to increase in rate of reaction. Now let's write the last topic, catalyst. Please write. Catalyst is a substance which increases the rate of reaction, which increases the rate of reaction without undergoing any permanent change. Now, generally you will see people answering what is a catalyst. Catalyst is something that increases the rate of reaction without taking part in reaction. Without taking part in reaction, but that is not true. If something is not taking part in reaction, how are they going to do anything? How are they related to the reaction also if they are not going to take part in reaction? So catalyst, they do take part in reaction, but they don't undergo permanent change. That means if you are giving catalyst to a reaction, the out will be in the product, the catalyst will come as it is. So some changes will happen in between the reaction. Catalyst will change its form in between the reaction, but at the end you are going to get the catalyst in the product as it is. Okay, so it does take part in the reaction, but it does not go any permanent change. Temporary changes happen in the reaction. Right, next, some remarks about this. Number 1 point. Catalysts take part in reaction, take part in chemical reaction, but does not get consumed. But does not get consumed in the reaction. Okay, so just for your explanation, guys, okay, so समझने के लिए please ध्यान दीजिएगा. For example, if I have a reaction something like this, I'm doing a reaction in which I have A, I have B, and I have to make a molecule that is AT. This is my expected product, but my A is also very stable, B is also very stable. Okay, both of these molecules are very stable, so obviously they are not going to react very easily. They're not going to react very easily. Now in comes what? The catalyst C. So now we have A, then we have B, and we have added a catalyst C. So this is stable. This is also stable, but catalyst is going to be very reactive. Catalyst is going to be very reactive. Now what is going to happen? Now the catalyst which is present, catalyst is going to bring, it is going to bond with A, and it is going to bond with B like this. It is going to bond with A and it is going to bond with B. Now what catalyst has done? Now A and B, which were very stable, they were not colliding with each other. They were not coming in contact with each other. They were very far away because of their stability. Catalyst is the thing that is going to bring them together. And if it is bringing them together, so see, catalyst has made bond like this. Now, when A and B are near to each other, the chances of this reaction and the bond formation increases highly. And as this AB bond forms, the C leaves as it is. So you can see that in the reactant also we have C, and the product also we have C as it is. But temporarily inside the reaction, it formed, this is the activated complex, the transition state. Okay, this is the activated complex, the transition state. So catalyst, as you can see, it is a completely new reaction. Now the complete mechanism has also changed, right? So it also gives an alternate path for the reaction. Okay, catalyst, it gives an alternate path for the reaction. Right, next, progress of reaction in presence of catalyst. Okay, so you can copy this. Now start slowly. There are many things which are happening here, but you can start slowly. I'll start first of all. This is the average energy of the reactant. This is the average energy of product. So that is not changing. Obviously, that is not changing. Okay. Now, this black line is what it is without catalyst, as you can see here. So it has a quite huge path because both, in our case, हमने देखा था A and B हमारे पास reactant है. These are very stable. So उनको activation energy क्या होगी? काफी ज़्यादा चाहिए. So they will require a very high activation energy. Now, cut to the point where we have a catalyst. Now, where the catalyst is present, it is providing a completely new pathway, and that is why this is the activation energy. Can you see the lowering of activation energy that has happened due to the presence of catalyst? Now, when the catalyst is present, now catalyst is what? It is very reactive. So it can easily form this particular compound, which we draw. This is my activated compound. It can easily form it because it is very reactive. We don't need to give too much activation energy. We don't need to give it too much activation energy. And that is why with catalyst, what is happening? The lowering of activation energy. Please write this down. I will give you what are different things. So we have EA, which is the activation energy. Without catalyst. Then we have EA dash, this part, this red one. This is the activation energy. With catalyst. Okay, what else? No, the other things I don't think you need to worry so much about. Important thing is that catalyst, it lowers the activation energy. Okay, it lowers the activation energy of
So should we draw this graph?
yeah. You have to draw this. Catalyst lowers the activation energy of the reaction by providing an alternate path for the reaction. Is everyone done? Yes or no? Please tell me.
No, sir.
Done? You're not done. क्या बोला आपने?
1 minute, sir.
Not
1
done,
minute.
sir.
Not done. आराम से लिखिए. Okay, and in the next class we are going to start electrochemistry. फर्स्ट में तो ऑर्गेनिक आप ही लोग का तो ऑर्गेनिक चल रहा था तो आप लोगों ने तो इधर केमिकल काइनेटिक्स स्टार्ट कराया ऑर्गेनिक हालोल्किन हालोरीन और हालोल्किन हालोरीन हो गया है अल्कोहल फिनॉल्स एंड ईथर एक जगह चल रहा है
Sir, can you scroll up? Sir, that's it.
Is there anyone who is still writing?
No, sir.
No, done. चलिए